Hello guys, here I'm going to describe understanding process states in Windows and Linux. Coming to the introduction part, definition of process. A process is not only a program under execution, but it is the active state of the program when it is executing and it has its own process control. A process is an instance of a program that is being executed. It includes the executable program, the program counter, the stack, the heap, and the data section. Essentially, it's the operating system abstraction of a running program. And a process requires other resources like memory, CPU, hard disk, and input and output, etc. Coming to next. The significance of processes are stated as resource allocation, multiprogramming, concurrency, isolation. Coming to resource allocation, the resource allocation processes are the fundamental units for resource allocation in an operating system. Multiprogramming can share system resources, improving system utilization. Concurrency processes can execute concurrently, providing the illusion of simultaneous execution. Coming to isolation, processes are isolated from each other, protecting system integrity. Next, process states in Windows and Linux are stated as five states. Those are new, ready, executing, waiting, and terminated. Coming to new, the new state of a process means the process is just created and is stored onto the hard disk. And coming to ready, the ready state of a process means the process is waiting for the CPU to be assigned. Next, executing. The executing state of a process means the process which is running and CPU is allocated to the process to complete the required action done by this process. Coming to waiting, the waiting state is a state in which the process is waiting for some resources that may be held by other process. And final one is terminated. This is the last state of process in which the process will terminate and the life cycle of the process will end with this state. We'll see an overview in the process states. Towards its life cycle, a process transition through various states. While the exact states may differ across operating systems, the core idea remains consistent. Typical process states are new, ready, as we discussed, running, waiting, terminated. Coming to new, the process in the certain in the creation phase, the process is prepared to be allocated to a CPU that's ready. And coming to running, the process is actively executing on a CPU that's running. What's next is waiting. The process is paused, waiting for an event like input output completion or the availability of a resource. And coming to terminated, terminated is the process has completed its execution. Process states in Windows. Windows typically uses a more complex state model than Linux. However, the core concepts are similar compared to Linux. Key process states in Windows includes running, ready, waiting, terminated, suspended, which are stated in the statement. The process states in Linux. Linux uses a detailed approach to define process states. Those are running, runnable, sleeping, stopped, and zombie. Coming to running, the running has different things. While running and runnable are usually lumped together, there are minor differences between them. The process is actively using the CPU. The runnable, the process is ready to execute but is waiting CPU time. The distinction between running and runnable is that a runnable process is ready and lined up to be run, but for whatever reason the CPU is not ready for it to be scheduled. Therefore, it is queued up to be running in a virtual machine environment. This is more common as physical CPUs are provisioned. Next, process states in Windows. Windows employs a set of process states to manage the life cycle of process. The primary states are running, ready, and waiting, terminated, and suspended. It is a program that present in secondary memory that will be picked up by the operating system to create the process. What are the other types we may discuss? State transitions and triggers. Our next point to state transition and triggers. The new to ready transition, the process is created, and trigger, the operating system sets up the necessary control structures and allocates resources for the process. When a new process is created, it doesn't start executing immediately. Instead, it enters the ready state, indicating that it is ready to run but awaiting for CPU time. This comes under the new to ready. Next, we'll go to running to ready. Its transition, triggers, and explanation. I've stated these 3 points as my thing. Coming to the definition, the process moves from the running state back to the ready state. Running to ready, a running process may be interrupted and moved to the ready state if a higher priority process needs the CPU. Alternatively, the running process might yield the CPU to improve multitasking, thus re-entering the ready state. Coming next to running to waiting, the process transitions from the running state to the waiting state. When a running process needs to wait for an event such as input, output, completion, resource availability, or user input, it moves to the waiting state, pausing its execution until the next event occurs. Waiting to ready, the process moves from the waiting state back to the ready state. After the event that pauses was waiting for its completion, the process transition back to a ready state, indicating that it is ready to run as soon as the CPU is available. Coming next to the running to terminated, the process moves from the running state to the terminated state. It completes all its instructions. When a process finishes executing its instructions, it enters the terminated state. In this state, the operating system releases its resources and removes it from the process table. Next, coming to suspended to ready, the process moves from the suspended state to ready state. A process in which suspended state has been temporarily halted, often to free up system resources or because it's waiting for a specific event. When resumed, it transitions back to the ready state, making it eligible for CPU allocation once again. The transitions and memory access. Coming to transition and signals, the 4 things to be discussed. Those are stop, continuous, term, cycle. Stop, SIG stop. Stop a running process transitioning it to be stopped state. Next, SIG continues a stop process, transitioning it back to a ready state. SIG term gracefully terminates a process, transiting it to the terminated state. Forcefully kills a process, transiting it to the terminated state immediately. This comes under SIG code. The process state transitions and signals. The process state transitions can be influenced by various factors, including system events, user interactions, and program behavior. Signals defined in the system library signal.h play a crucial role in triggering these transitions. By using signals, the operating system and users can effectively manage and control processes, ensuring smooth and efficient execution. Signals enable process to respond to various events, making them an essential part of process state management. Key signals and their impacts. SIG stops, suspend the process. SIG continue, resumes a suspend process. SIG term request a normal process termination. SIG kill forces immediate process termination. Coming to next, the memory access during the transition. Primary memory, RAM, used for immediate execution and processing of processes. When a process transitions to running, it must be in RAM. Secondary memory, that is disk storage, used for swapping, paging, and file access. When a process transitions to waiting, it may be swapped out to secondary memory if RAM is needed for other processes. Swapping and paging involve moving parts of the processor's memory between RAM and disk to manage limited efficiently. The examples are stated. During an I/O operations, data may be read from or written to disk, causing the process to transition to waiting blocked until the operation completes, input operation and output operation completes, at which point it transitions back to ready. When a process is stopped, SIG stop, its current state is saved in RAM and it remains in RAM until continued SIG continues, if we use the SIG continues. Yep, is my PPT. Thank you for watching.